The Theory of Everything by Dr. Alon Giladi.
Article 7. Being Karl Popper. Well, in 1934, Professor Karl Popper published his famous book, The Logic of Scientific Discovery. In this book, Popper presented his fundamental principle, according to which a theory is a scientific theory if and only if it is falsifiable. That is, if there is a principled possibility of putting it to the test of observations or experiments that may refute it. According to Popper, scientific progress is not achieved through an inductive process, that is, by accumulating observations and deriving a theory from them, but rather by positing a bold hypothesis that becomes a theory, which is tested against reality, against experiments, and against observations. This theory stands as long as it is not logically refuted by the observations. In simple terms, if a certain theory is true, we expect observation X. If in fact we observe non-X, the theory is refuted and falls, and a new theory must be put in its place. The new theory, according to Popper, should be not only falsifiable, but also more informative than its predecessor. At the heart of Popper's view is the notion that science repeatedly advances toward the truth, although it will never attain it with certainty and absolute certainty. It is a constant striving for objectivity, an approach to a truth that will never be fully attained, by replacing refuted theories with bolder and better theories. Against this position of Karl Popper, an early and significant criticism was leveled by Pierre Duhem in 1906 in his book The Aim and Structure of Physical Theory. Duhem argued that it is not possible to test a single theory by means of a single case or a single observation. According to him, refutation never operates against an isolated theory, but against a set of assumptions underlying it. That is, when a particular observation contradicts a theory, this does not necessarily mean that the theory itself is wrong. The flaw may lie in one of the background assumptions, in one of the auxiliary assumptions, or in the accompanying theoretical framework. In 1951, Willard Van Orman Quine developed this line of thought in his book Two Dogmas of Empiricism, and took it to a more radical position against Popper. Quine argued that when a theoretical thesis is obscured, it is impossible to determine with certainty which component of the thesis has failed. That is, there is no sharp and clear way to distinguish between the core of the theory and its auxiliary assumptions. According to Quine, Popper's position is too inclusive and even naive, since it does not distinguish between central, comprehensive, and important theories and specific components within those theories. It ignores the complexity of an entire theoretical system. Furthermore, Quine argued that a study of the history of science shows that adopting Popper's approach strictly would have prevented scientific progress. For example, he claims that Galileo would not have adopted Copernicus because at that time there were many observations that allegedly contradicted the heliocentric model. From this, Quine concludes that central theories, such as those of Newton or Einstein, were in fact protected from immediate refutation and were not overthrown because of one or two contradictory observations. According to Quine and Duhem together, science does not progress according to the simple Popperian model. When an observation appears that does not fit with a central theory, the entire theory should not be immediately overthrown, but rather one should examine where the error lies, in some component of the theoretical system, and try to correct it instead of rejecting the central theory itself. It should be noted here that this is a problematic narrative that is perhaps aimed at an institutional goal according to which, according to Popper, one observation is enough to overthrow an entire theory, and that's it. A proper observation about Popper would be that repeated tests of both the observation and the theory should be required until logical certainty is formed that is also refutable, as opposed to the ignorance that distinguishes between the overall theory that is not tested and its parts that are tested separately from it. It seems that after the radical clash between the Duhem-Quinn position and the position of Karl Popper, Professor Thomas Kuhn appeared in 1962 and supposedly offered an intermediate approach as part of his well-known book, The Structure of Scientific Revolutions. Kuhn claims that science in the past developed within a pre-paradigmatic period, while modern science develops within paradigms. And what is a paradigm? A paradigm is a comprehensive system of basic assumptions, problems, and accepted solutions. That is, a frame of mind shared by the dominant scientific community. According to Kuhn, scientific development occurs within an existing paradigm, within a period he calls normal science. During the period of normal science, there is no attempt to challenge the paradigm itself or the central theory. An important theory, as defined by Quinn, is not a candidate for refutation, but serves as a framework within which specific problems are solved. The experiments are not refutation experiments in Popper's sense, but rather solution experiments, attempts to resolve difficulties and anomalies within the framework of that paradigm. According to Kuhn, modern science no longer operates in a pre-paradigmatic state, but within periods of stable paradigms, governed by shared assumptions and an accepted scientific community. This is a state of normal science. And when did Karl Popper enter the picture? According to Kuhn, Popper is activated only when the paradigm itself collapses, an exceptional and rare event, when too many anomalies accumulate that can no longer be resolved within the existing paradigm. Then, and only then, does a scientific revolution occur. One paradigm falls, and a new paradigm, a new overall theory, arises in its place, and a new period of normal science begins. Thus, according to Kuhn, science progresses in cycles, a stable paradigm, accumulation of anomalies, a scientific revolution, a new paradigm, and then again. Scientific revolutions are rare, from Newton to Einstein, and from Einstein to the present day. It seems that, according to Kuhn, we have been within the same dual paradigm for about 120 years. Einstein's theory of relativity on the one hand, and the quantum mechanics of Planck, de Broglie, Bohr, Heisenberg, Higgs, and others on the other. But the approach of Duhem, Quinn, and Kuhn is also an extremely problematic one. Why? Because there is a fundamental difference between a historical description of how science developed and the transformation of this description into a binding norm, a doctrine that must be followed. The main problem is that when the paradigm approach is adopted as a guiding principle, what is actually obtained is a closed system resembling a cult or a subjective religion. The scientific community becomes the factor that determines what is permissible to challenge and what is prohibited, which parts can be corrected, and which parts are sacred and immune from refutation. In such a situation, the central theory does not stand up to a real test, but only specific corrections are permitted, at the discretion of the dominant scientific community. This is a mechanism that is more reminiscent of a coercive religious system than a scientific doctrine rooted in freedom of research. For example, we can make a historical copy-paste in this regard from the case of Amenhotep IV. Amenhotep IV addresses the priests and the pagan system, which is rich in power, positions, and resources, and tells them, "You are wrong. Instead of hundreds and thousands of gods, there is only one God, the God of the sun." A concept that made a lot of sense for its time, in light of the central role of the sun in the formation of life. This doctrine was met with fierce opposition from the priestly system, as it threatened the centers of power, positions, and control. Immediately after the death of Amenhotep IV, idolatry in ancient Egypt returned, and even more so. And what remains of it today? Only antiquities, not truth. The same is true of science. Whether we look at specific observations or comprehensive theories, science is supposed to operate according to scientific principles and not according to mechanisms of silencing, authority, and the defense of paradigms. Once the approach of normal science is accepted as a binding norm, the scientific community itself becomes the measure of truth. And when the central theory does not match observations, the theory is not tested, but new entities are invented. Dark matter to sustain the theory of relativity, additional constants and variables, and new particles in quantum mechanics, particles that did not exist and were not created, that appear out of nowhere and disappear into nowhere. All of this in complete contradiction to physics and in complete contradiction to the laws of nature. Even if we choose to follow Thomas Kuhn and accept the framework of paradigms and normal science, it still becomes clear that the anomalies in the two fundamental pillars of modern science have accumulated to an extent that can no longer be denied. These are anomalies that are not marginal and not isolated, but rather ones that strike at the very heart of each of the theories. When we look at the theory of relativity, it becomes clear that it does not work at the level of elementary particles in small reality, but the problem does not end there. The theory of relativity also does not work in large reality. It does not provide a coherent description of the Big Bang. It does not stand at the singular point of black holes, and it does not consistently explain the non-collapse of the universe. Even in these fundamental senses, the theory simply does not work. A parallel observation of quantum mechanics leads to a similar conclusion. It also does not operate in the natural reality beyond the dimension of small particles. From a certain limit onwards, it collapses. But instead of asking whether this collapse indicates a fundamental error in the theory itself, we continue to develop it more and more. Thus, we are presented with a reality of uncertainty, of chance, of matter that is also spirit, of entities that are simultaneously in the same place, and of the claim that the observer influences the very outcome of the experiment. To this are added particles that do not fit with observations and the fundamental laws of physics. Not the quarks, not the gluons, not the Higgs, W and Z particles, nor other particles that have been proposed. And instead of stopping and re-examining the foundations of the theory, instead of positing a real alternative to these two masters, another alternative theory, they try to unite them by force into a theory of everything. This is how theories such as string theory and the like are born, which in the end are nothing more than a continuation of error upon error, and even more so, an attempt to unify two central theories that are not valid from the start, theories that the scientific community clings to even though they do not hold up against the most fundamental observations of the universe.
All rights reserved to Dr. Alon Giladi.